All right, another nonlinear example here. And because both of these have x squared and y, I think the elimination method is better. I wouldn't do the substitution method because I'll have to divide by a coefficient and then I'll have fractional coefficients, which I don't like. So that's just me. Try it if you want to. And I'm going to eliminate x again. Go figure. So multiply the other equation by the other coefficient and subtract. And we end up being able to solve for y, plug that back in, and solve for x. Remember when you solve for that square to do the plus or minus. So we'll have two values for x there. I'm going to double check them again. So plug the x and the y into both equations for both points and check it out and make sure that everything is good. And they are. So those are our two solutions. Now, I might just caution and say we don't always have two solutions to these. My examples do, but if you know what the graphs look like, then you might be able to visualize the intersections. So a circle and a parabola, for example, could have up to 4. A line and a circle or a line and a parabola could have up to 2. And we could have no solution for these or 1 or whatever up to that number that I just said. We try not to make these crazy with more than 4, with really crazy shapes there, but it might help you in going, hey, I found 2 solutions. There could be more. And then maybe you forgot, I don't know what. Anyways, I'm done.